Okay, so today, in the next couple of days, we're going to work on classifying triangles, the angles of triangles, and the different properties of isosceles triangles. So to start out with, to classify triangles, you classify them either by the angles or by their sides. If one of their angles is 90, then it is a right triangle. If one of the angles, and only one, is greater than 90, then it is obtuse. Now, if all of the angles are less than 90, it's considered acute. And if the three angles are all equal or congruent, then that makes it equiangular. And please keep in mind, if they're all equal, then they're all going to be 60 degrees. So if each one of them is 60 degrees, then it's equiangular. All right. Now, sometimes we classify them by their sides. If you have at least two sides that are congruent, it's isosceles. If none of the sides are congruent, then it is scalene. If all three sides are congruent, it's equilateral, because lateral stands for sides. Equiangular and equilateral mean the same thing, sort of. If a triangle is equilateral, then it is equiangular. If it is equiangular, then it is equilateral. All right, so using those properties, let's see if we can find the measure of some sides. So if we go here, it says find x and the measure of each side of the equilateral. So the fact that it's equilateral, that means all the sides are the same. So JA is x plus 9, AG is 2x, and JG is 3x minus 9. Since they're all equal, it doesn't matter which two I use. All I know is that I want to set two sides equal to each other, and it does not matter. I'm going to choose these two. So I've got 2x is equal to x plus 9. Since they're equilateral, they are equal to each other. If I subtract x from both sides, I get that x is 9. So now that I know that x is 9, I can go in and plug it in. So this would be 2 times 9, which would be 18. So AG is 18. 9 plus 9 is 18. So JA is also 18. 3 times 9 minus 9 is 27 minus 9, which is, oh my goodness, it's 18. That's because it's equilateral. Okay, what about this one? This one says, find x and the measure of the unknown sides of isosceles triangle. So since it's isosceles, that means two sides are the same. So they tell me that EF is 4x and FG is 2x plus 6 and EG is 14. So since these two sides are equal, then I'm going to set this equal to each other. So 4x is equal to 2x plus 6. So find x. So subtract 2x from both sides, and we get 2x equals 6. Divide both sides by 2, and we get that x is 3. So if x is 3. Now all I got to do is go back and plug it in. 4 times 3 is 12. Well, EF is 12. Well, if it's isosceles, this side better be 12 also, but we're going to check. 2 times 3 plus 6. 6 plus 6 is 12. So therefore, we do have an isosceles triangle. All right, angle sum theorem. Okay, this means that the sum, so when you add up all the angles in the triangle, so this angle plus that angle plus that angle, it's going to add up to 180 degrees. So no matter what, it's going to add up to 180. So for example, if I want to find angle R, I know that there's 180 degrees inside. So you add the two, you know, 110 plus 30 is 140. And then you take 180 and subtract it. So you get 40. So angle R is 40. Well, if angle R is 40, angle O is 30, and angle C is 110, since 110 is greater than 90, then this is an obtuse triangle. Okay, now over here we have two triangles, but I know angle 1 and angle 2 are congruent because they're vertical. So all I got to do here is add 84 plus 54, and I get 138. Now take 180 and subtract 138, and you get 42. So that means angle 1 is 42. Well, if angle 1 is 42, so is angle 2, because remember, they're vertical. So now if angle 2 is also 42, now I add these two angles and I do the same thing. 79 plus 42, so 9, 10, 11, 7, 11, so that's 121. So 180 minus 121 is 59. So now I know that angle 3 is 59. All right. Now there's the exterior angle theorem, and the exterior angle theorem says that if you have an angle outside the triangle, so if I take one, see how we have this one triangle right here? If I take this side and I make it longer, then this angle right here is going to be equal to these two over here, the ones that don't touch. See how these two don't touch this outside? These two are going to add up to equal that one. So for example, if this one was 80, then these two would be 50 and 30. 50 plus 30 is 80. So let's see what that looks like. So if I know the outside angle is equal to these two when I add them together, that means 60 plus x, because I don't know angle 3, so we'll call it x. Well, if I subtract 60 from both sides, I get 65 is my x, so that means angle 3 is 65. Okay, so let's try that over here, because we have this angle is outside, this angle is outside, that angle's outside. So see how they're all outside? So let's see what happens now. All right, so first of all, I'm going to go ahead and find this angle right here, because if I do, that means I found angle 2. So if I add these two together, 78 and 50, I get 138. So take 180 and subtract 138, and we get 62. So that means this angle right here is 62. Well, if that's 62, so is angle 2, because they're vertical, so 62. Now remember, angle 1 and angle 2 form a linear pair. So think about this. If I took 180 degrees and subtracted the 62, I get 118. So isn't that what these two, I'm sorry, not 118, yes, 118. Okay, apparently I can't add the 128, so this is 128. So if I take 128 from 180, I get 52. So that makes this angle 52, not 62. I am sorry about that. I should have grabbed my calculator beforehand. So now if I take 180 and subtract 52, I get 128, which is what I should have gotten, because angle 1 and angle 2, remember, they're supplementary because they're a linear pair. So that makes angle 1 128, because they're supposed to add up to 180. But if you think about the exterior angle theorem, these two angles right here are supposed to add up to what this one is out here also. All right, so now using the same concept, I'm going to erase this, and I'm just going to write in the 52 here. So this is 52, and this was 128. So now, if this angle here is 120, doesn't this one have to be 60, and so does this one, because they're a linear pair, and then those two are vertical? So that makes angle 4 60 degrees. Now I can find angle 3, because these three angles need to add up to 180. So if I take 52 plus 60, I get 112. If I take 180, because that's how many degrees are inside, and subtract 112, so 180 minus 112, I get 68. So that means angle 3 is 68. And then last but not least, angle 5 is way out here by itself, so it should be the sum of this angle plus this angle because it's exterior. So if I take angle 5 equals 60 plus 56, so that's 116. So that means angle 5 is 116. All right. Now, there are some corollaries that go with triangles, and these are true always. For example, if you have a right triangle, the acute angles, that means the other two angles. So we have a right triangle because this angle is 90. So that means angle 1 plus angle 2 are going to add up to 90. So that makes them complementary. All right. And then you can only have one right or one obtuse angle in a triangle. So you can either have one that's 90 or one that's bigger than 90, but not more than that. Because think about it, if you had two 90-degree angles, that's 180 degrees, but there's another angle. So then it would never work. The next thing is, like I said on the very first, if it's equilateral, it's also equiangular. And each angle is 60. Okay, this is true for all equilateral triangles. All their angles are always 60, no matter what, only if it's equilateral. All right, so now we're going to figure out if it's a right triangle. Okay, so sometimes we can find out if it's a right triangle just by using the Pythagorean theorem. Okay, so if I take the Pythagorean theorem and I say, okay, the longest side has to be C. So if I make this C and 8's the biggest number, so that's my C. The other two can be my A and my B. So what you do is you say, okay, the Pythagorean theorem is A squared plus B squared equals C squared. So 5 squared plus 12 squared equals 13 squared. I'm just plugging the numbers in. So I get 25 plus 144 equals 169. Since 169 does equal 169, then yes, this is a right triangle. So let's try it over here. 4 squared plus 6 squared equals 8 squared. 4 squared is 16. 6 squared is 36. 8 squared is 64. 16 plus 36 is 52. 52 does not equal 64. So no, this is not a right triangle. Almost done. All right. Next thing, these are the properties of an isosceles triangle, and this works for all isosceles triangles, okay? These two sides right here, actually, let's start here. Let's start at the tippy top, okay? The tippy top angle is called your vertex angle, okay? This angle up here is your vertex angle. So if you take your vertex angle, so we're going to call this the vertex angle, and I'm going to put two little marks there. The two sides that come off of the vertex angle, those two sides are equal to each other, and those are your legs, kind of like your legs are equal to each other. So these two legs are equal to each other. Now these two angles down here at the bottom of your legs, kind of like your feet, these two are called your base angles, and your base angles are also always equal to each other. So even if I don't tell you, hey, this is a isosceles triangle, so if I were to draw this, and all I told you was this, you automatically know, hey, that's an isosceles triangle, and I also know that those two angles are equal. So let's do some practice with that. So if the two sides are congruent, then the base angles are congruent. And remember the inverse. If the two angles are congruent, then the two sides are also congruent. So if these two sides are congruent, then these two angles are congruent. If these two angles are congruent, then these two sides are congruent. That's always true. So now we have, if an isosceles triangle, in an isosceles triangle, the legs are congruent and the base angles are congruent. So now let's see if we can figure some things out using this triangle over here. Each one of these problems is different, so we're going to have to fill in and erase as we go. So triangle DIS is an isosceles triangle. DI is congruent to IS. Make sure you put those congruent marks. Now remember, if these two are equal, so are these two down here. So what is the vertex angle? The vertex angle is the one that's at the top of the legs. So that would be angle I. So angle I is your vertex angle. So if DI is 7, then guess what? IS is also 7. If angle D is 70, guess what? So is angle S. If angle D is 80, well, if angle D is 80, so is angle S. But what's angle I? Well, how many degrees are in here? 180, right? So if you add the two angles you know and subtract from 180, you get that this is 20 degrees. If angle I is 100, so now we're going to go up here and we're going to say angle I is 100. So now this one's 100. Well, since these two are the same, I can just take the 180, subtract 100, get 80, and then divide by 2 because there's two of them. So that makes each of them 40 degrees. So if DI is equal to IS, then angle D is congruent to angle S. If angle D is congruent to angle S, then DI is congruent to IS. All right, last little bit here. If D is 3x minus 20, so this is 3x minus 20, and S is 2x plus 5, well, we know they're equal. So set them equal and find x. So I'm just going to go over here and I'm going to subtract 2x from both sides. So that makes x minus 20 is 5. Add the 20 to both sides. So x is 25. So I'm going to go over here and x is 25. Then to find the measure of angle D, just simply go back and plug it in. 3x minus 20, so that means 3 times 25 minus 20. 75 minus 20, 55 degrees. So angle D is 55 degrees. All right, that wraps up some triangle stuff. See you guys tomorrow. The end.